Welcome to the lesson on the quotient rule, part 1. So in this lesson we're going to develop a quotient rule. So recall from previous lessons, we have a rule for sum, difference, and products of functions. So if you have the sum of f plus g, then the derivative is just the derivative of f plus the derivative of g. Easy one to remember. Same difference, almost the same. F minus g, it's the derivative of f minus the derivative of g. So the two were very straightforward. The product rule is a little bit trickier. So if you have the derivative, if you want to do the derivative of f times g, you can't just do the derivative of f times the derivative of g. It actually turned out to be the derivative of f times g plus f times the derivative of g. So now our question is, what is, if we have f over g prime at x, what does that equal? Could we come up with a sort of a rule to express this in terms of just f and g? And the fact that our rule for products wasn't quite so simple as the rule for sum and difference probably suggests to you that the rule for quotient won't be quite so simple as just taking the derivative of the top and the bottom. So how do we get the rule? You might suggest, we might have to do something like we did for the product rule. If you remember how we got that, we had to actually go to first principles. But we won't do that in this case. We'll actually just use this rule right here. We'll just use the product rule to come up with our rule for quotient. So how will we do that? Well, let's say h at x is the quotient, is f at x over g at x. Okay, and we want to know what's the derivative of this. We want h prime at x, right? We want the derivative. That's not a question. That's what we want. So we want the derivative of this. Well, we don't have a rule for quotient, but we do have a rule for product. So could I express this as a product? And the answer is yes. How could you express it as a product? We'll multiply both sides by g at x. So if I multiply this by g at x, g at x times g at x, right? So I just multiplied both sides by g at x. So these g at x go away. So we'll have h at x times g at x equals f at x. So now we have it as a product, so let's differentiate with respect to x. So how do you take the derivative of this? Well, that's the product rule, right? Derivative of the first times the second plus leave the first times the derivative of the second equals, I have to differentiate that side too, so f prime. Now remember, what are we trying to get? We want h prime, right? Because h is the original quotient. So let's isolate for h prime. So I'll have to subtract this from both sides. If I subtract it from the left, it goes away. Oh, sorry, I did the wrong thing. I want to subtract. This still had the g at x, right? And then I'm subtracting h at x, g prime at x. Right? So I was subtracting this from both sides. And then I'll divide by g at x. So h prime at x equals f prime at x minus h at x, g prime at x, all over g at x. Now one thing we don't, we have a formula. The only thing we don't totally like is that there's an h in here. We'd rather have everything in terms of f and g. So just remember that h is equal to f over g. So now we'll put that right there. Just make that substitution. So minus fx over gx times g prime x all over gx. And now we don't like the whole fraction in a fraction, so let's get a common denominator on the top. So common denominator of gx, this is the numerator. So we'll have to multiply f prime times gx minus fx times g prime x. So that's the numerator just, and then that's all over g at x. So we still have fraction and fraction, so now let's just multiply by the reciprocal of this. So multiply by, instead of g over x, multiply by 1 over g. So you would end up with f prime at x, g at x, minus f at x, g prime at x, all over, and then these gx's will just be multiplied, so g at x squared. So that's the derivative of h, which was f over g. So that's derivative of the quotient. So that's your quotient rule. Okay. Just so you see it another way, I could write that in Leibniz notation, dy by dx of f at x over g at x, which is equal to the derivative of f at x times, leave the g at x, minus f at x times the derivative of the g at x, this is the bottom, all divided by g at x squared. Okay. So, I mean, that's your rule. Sometimes, here, I'll write it in English. No notation, just the quotient. The derivative is equal to the f, which is always the top. So the derivative of the top times the bottom, which you leave, minus leave the top times the derivative of the bottom, all over the bottom function squared. Okay, so these are the notations, and then this thing maybe helps you remember. It's always the derivative of the top times the bottom minus leave the top times the derivative of the bottom all over the bottom squared. One point, it's really important that you keep the order correct here because of this minus. If you do the derivative of the bottom first, you'll be off by a negative.